Welcome to the end-use automotive part production with SLS 3D printing. My name is Chris. I'm a sales engineer here at Formlabs. I will be here for the first 5 or 10 minutes just to give an introduction of who we are. I am happy to introduce Matthias, our guest speaker, a manager of seat prototyping from Brose. As we go through all sorts of content and photos and information, questions obviously will arise. What we will do is have a Q&A section at the end of the presentation. So any questions that come up, jot them down in the Q&A section. For general chat, just saying hello and things like that, you can use the standard chat function. Quick agenda, I will give the introduction to Formlabs, a basic overview of SLS 3D printing, which is our focus today. And then Matthias will take over, go over all the latest and greatest of Brose and their additive manufacturing parts and processes and fun stuff like that. So I'm excited to hear about it. So Formlabs as a company, we are a global manufacturer of SLS and SLA 3D printers. We also manufacture all of our own resins, as well as some post-processing equipment. So we started in 2012. Since then, we have grown into 135,000 install base, 40 plus materials, a lot of parts being printed off of those. And with that, we have over 800 employees and offices all across the globe. So I'm based in Boston. We also have offices in Berlin, Budapest, and then a few in APAC. A quick little highlight into the current 3D printing portfolio. So for those that may not know, we did recently release the Form 4 and Form 4B, our latest line in the stereolithography or SLA printers. We also have a large format SLA printer, as well as the associated washing and curing stations, which you need for post-processing for all sorts of end-use parts. On the SLS side, that is where we have the Fuse Plus, which is our SLS 3D printer that utilizes nylon powder. And then we have a Fuse Sift, which is what you can use to recycle, reuse, and reclaim your powder. And then a Fuse Blast to get clean of the touch parts every single time in about 15 minutes. 3 main technologies within 3D printing: SLS, SLA, and FDM. I'm sure most of you have seen a FDM printer in the past. That is going to be your filament extrusion, direct drive printers where you're producing all sorts of parts. SLA, that is where Formlabs first made its name back in the early 2010s with the Form 1. So that is your UV cure process where utilizing a photopolymer or a resin. We are printing ours upside down to get your end-use parts. SLS, which is what Matthias will be talking about in some of his parts, is utilizing nylon powder, which is a thermoplastic, and we are using a 30-watt laser to basically have it preheated and then add just enough energy so very specific areas and sections can get melted, sintered, and then hardened into very high accurate and repeatable parts. When it comes to use cases, what you can do with each technology, obviously every single technology has its specialty, its use case. I think the best additive labs will have a mix of all 3 technologies. FDM, very quickly with the basic prototyping and hobbyist applications. As you get into the SLA and SLS materials, you do have more certifications when it comes to biocompatibility. If you're looking to do something for, say, surgical guides, or if you're trying to make a denture model or anything like that, that requires direct contact with either a person or anything like that. As you grow into more of the engineering-based materials, that's when you are looking into functional prototyping and now production parts. So with that segue and production parts, I would like to introduce Matthias from Brose. Take it away.
Yeah, hello everybody. Yeah, thanks for having me. So yeah, quickly to my person. I'm with Brose since a little over 15 years. In my current role, I'm responsible for the seat prototyping of North America region. With that being said, in prototyping, we have to, of course, go with the time. So we, of course, have additive technology here. This is also something that falls under my umbrella. At Brose, we do have our headquarters for additive technology actually in Germany, where also our headquarters generally is located. In that facility, we do some R&D stuff with the technology. We overcome a couple of patterns and have greater capabilities that we have here in North America for the North America region. Therefore, our intent was to build a location that kind of acts as a job shop and complete tasks quickly on a very low budget, I would say. Therefore, Formlabs is for us our partner here because they offer just a turnkey solution without all the finicky. So yeah, that helps a lot. We're leveraging 3D printing a lot over here to reduce cost, time of manufacturing. We use that technology, of course, for prototype parts as well as for some serial production parts. So when it comes to our headquarters here, we're located in the Urban Hills location. We are split in different buildings. In the building that I'm located, actually, we just do development, prototype, and testing. In those locations, of course, 3D printing is as well located, and we utilize the equipment for different applications. I'm going to walk you through each one of them now. So if you have questions, feel free to add them. Like Chris mentioned, one of the topics I won't answer to is cost. So yeah, I hope you understand. Besides that, every question is very welcome. So when it comes to SLA technologies, we have basically all printers that Formlabs has available, SLA and SLS. So we partner with Formlabs since a long time in our Germany location, basically since the first hours. So yeah, that being said, to SLA, actually, the most of our SLA applications are really used for rapid parts that we need. They also used in like prototyping applications, but we won't use them in serial applications. Reason for that is only the UV resistance. There are some options out there to coat the parts, but that's not interesting for us overall, because therefore we just use SLS technology. So the SLA technology itself helps us in many cases. I'm going to show you a handful over here. One of the good example are the seat dampeners. So the seat dampeners is a component actually that helps us to reduce noise level in the seat structures. On this particular example, we needed 1,200 pieces. Problem was, of course, the supplier that makes those parts for us currently in serial production is located in a China location. Therefore, we have a minimum order quantity buy, which was way too high for us and up in the millions. So in order to avoid that problem, we decided to print them over here. We do that also on some other parts, especially when shipping is a problem for us, especially customs, etc. Then we 3D print those parts. The great aspect for us when it comes to the technology is that you can change over from one material to another super quick. That allows us to print different styles of parts. So here you have seen a flexible rubbery type of part. And on the next example, you will see a more rigid part. Those help us to set up our weld station. So what you see here in the picture is actually the inside of one of our laser weld stations that we have here. As you can imagine, on the seat structure, around 95% of the seat structure itself is metal. That comes because of all the safety regulations that we have to maintain. In order to mate those components together, we usually use laser make or mag welding. So for all of those kind of setups, we need to have a weld fixture available. And that is what you can see in the picture. Problem for us is those weld fixtures are available way earlier than the physical parts, just because of manufacturing times and tooling times, etc. So in a traditional way, we always install the fixtures, waited until the parts arrived, and then later had to perform the setup. So problem is that costs us a lot of time, and the waiting time was kind of useless for us and definitely a waste. So we 3D print those parts on the SLA printers and then introduce them to the weld station. Sometimes, and that's what you can see over here, we have to print a pretty significant size part. So therefore, we just add puzzle pieces in the components and split it basically in half, print two halves, connect them together, and then glue them up with either super glue or resin itself, and then cure it in the UV chamber. So that helps. And then after that, we install the part, as you can see here in the station. And that allows us to first off make a buy-off on our weld fixtures, meaning we outsource the fixture build, and then the supplier actually sends the fixtures to us. Before the supplier sends them, the buy-off is taking place, and therefore we have to use physical parts to actually see if everything fits from a geometry perspective. So this is all done with those parts, and then as soon as the fixtures are released and in our location, we actually have now the ability to teach our robots as well on the welding perspective. That means we can train a robot already on the physical part that we have, where he has to move. Of course, we cannot try the welding operation, right? But that is an option. In addition to that, the heat-resistant material that Formlabs offers is also capable to print some of those blocks. Not shown here in that picture because we have not done that on that particular fixture at that time. Where that becomes interesting for us is usually in prototype, we're only one call away from a change. I think a lot of you can relate. So therefore, we have to adapt to changes rather quick, and that's where then the heat-resistant material becomes very interesting. So we just design the block, print it in-house over here, and then install it because of its heat resistant, and actually allows us to maintain its form and shape even under high heats here with the welding. So we had some good wins over here. So the next slide over here, you can actually see after we dialed in the part with the 3D printed model, then we can install the actual metal parts and weld those metal parts together. So in this case, it was laser welding. And then part of our Brose portfolio here is too that we have a paint line. So when we introduce those, of course, metal printed parts into the paint line here in the picture, you can see both prototype parts as well as serial production parts. This is a snapshot out of our new Boston location, which I will get later a little bit into. Yeah, when it comes to SLS, we do have a fleet of SLS printers over here between the, I would say, previous model Fuse 1 and then Fuse Plus. We also have a SIFT and a media blaster. For us, it was always very important that we have a system available that is low maintenance, because of course, doing that here in the US, which is considered a high-cost country, we definitely have to watch the labor cost quite a lot. So Formlabs is very creative when it comes to solving those kind of problems because of the SIFT and the tumbler that they offer. After we have with the SLA parts a proof of concept, then we go usually into like larger scale prints with SLS. A little different to a lot of other companies. When we talk prototype parts, we talk in several hundreds. So it's not that they have to print for prototype 1 or 2. It's usually somewhat between a minimum of 100 up to like 1,500 parts that we have to print. So yeah, that being said, it's quite some volume. And we also use the SLS technology for some end-use parts. So that allows us to print like high volume of parts. And you can see with the fleet that we have over here on hand, we are able to maintain quite some heavy loads. I will show you some examples here in the next slides. So this is a good example of prototype parts for us. So on those parts, we have to print 800 pieces for our current prototype build. We can fit 50 pieces in one chamber. This part is actually a gearbox housing. And of course, the big win for us over here is we have saved several thousands of dollars, tens of thousands of dollars actually for a tool, and can print it here by ourselves. And even better, right, in case we see a design change, right, we can adjust that right away. This is a fairly new part to us, so I wouldn't be surprised if there are changes coming. So that always helps us, and yeah, we can trial parts way earlier. So this also helps us in another way, because the part later becomes as well necessary for our industrial engineering team. The industrial engineering team also needs to make buy-offs on serial production tooling. And this usually has to happen as well with some physical parts, same like you have seen it earlier with the weld fixture. And in this particular case, we were able to provide then to serial production already 3D printed housings, and they can try to mate them together like they would do later in the serial production line. That allows us to get a head start over here and then also save some costs on it. Now going into serial production items, the clip that you can see over here is actually installed in an BMW X7. So if you see an X7 on the road, there's a Formlabs part in there that drives happily around it. And yeah, we have to print roughly 200,000 more of those parts. Yeah, the current demand is around 1,400 parts. 16,000 parts per month. And yeah, we can fit around 1,400 parts in the chamber. So how did it come that we decided to use 3D printing for an end-use part? Of course, we had to go through the approval process with the customer, etc. Need over here as well, because we have prototyping and test in one location. So we were able to actually test the components. We were able to prove that they can withstand the lifetime of a vehicle. So that helped us to show later our OEM that this part is able to be used in the structure. And in addition to that, we wanted to implement the part rather quick. As you all know, it takes quite some time to get an injection molded tool ready. We would need several cavities in order to keep up with the quantity. Cooling lines have to get added to the tool, etc. Yeah, with 3D printing, we were able to supply parts within the first week of being alerted. And in addition to that, of course, we're very flexible when it comes to the quantity. As you can see with the amount that fits in a chamber, because this is a rather small part, we can scale that up pretty good. So right now we're able to, with just one printer, to keep up with that amount. Of course, we printed on the Fuse 1 Plus, which is way faster than the previous Fuse 1 and provides us the same results when it comes to the print quality. So therefore, we didn't have any issues or concerns. We ship those parts actually to our Mexico location, so we have to build kind of a bank in order to account for the shipping aspect of things as well. Pretty interesting too. We had to do some 3D measurements over here too, like with our scan system, and to correlate those parts as well to the print. And yeah, we see a very good consistency in the prints as well that allowed us to use those 3D printed parts. We had several applications for similar topics already where we used, we call this process gap printing actually, where we had to use 3D printing in the duration time between a tool being, or a design change is being asked and the tool is being ready. That gap over there, what it takes to fill, we actually use 3D printing, and then later, as soon as the tool is available, we go over to the tool part. But that allows us as well to save still a lot of money because we don't have to expedite the tool, have to get, have no, I would say, additional charges for the tooling time. And yeah, we can make sure that we get the proper approvals for the tool, but we have done as well parts that we printed all the way until the end of the lifetime. Another example is this part over here. This is actually a cable release pulley. Yeah, we need to deliver 1,000 parts per week to our OEM. We could fit 144 parts into the chamber, and we went through a similar process like you have seen before on the previous slide. What is also very interesting is to combine both technologies. So on the left-hand side, you can see basically the assembly part that later goes into seat structure. The part shown on the left-hand side is actually a seat suspension mat. So that's where the load is actually later on the seat structure itself. And we used both technologies in this case. So as you can see, the grayish part on the ends of the wire are SLS, and then the white parts are actually printed with the flexible material on the resin printers. And here we actually had to do an overmold per se, which is something that, of course, is very complicated to do in an injection molded tool and very expensive. So we redesigned basically the powder parts to snap over the wires, and the flexible parts, they just have a tiny slot. When they come out as a green part, meaning just fresh out of the printers and still being soft, we take them off the build plate, snap them over the wires, close the gap with some additional resin, and then bake them into the oven to actually create a physical overmold. So yeah, that helped us actually to make this work. And yeah, that is something where both technologies become really handy actually to use in combination. Another item that helps us a lot is actually reverse engineering. So in prototyping, very often we run into an issue that we have parts that we have to modify physically to actually make to work, right? Or when we build like show samples for auto shows, etc., right? Then we can modify the part, scan it after the modification, and then reintroduce it to the printer to duplicate those parts. So yeah, that helps us out a lot because it really cuts down timing. And the scanning aspect of things, of course, creates a 3D model, but not a drawing. So outsourcing that part and have it done the traditional way without a drawing is always hard. So that is all something that we don't have to worry about with this 3D printer. So yeah, we can just directly feed it back into the printer and have it done that way. Yeah, earlier I mentioned our New Boston location, so you can see the, I would say, stats from the New Boston location to right on the presentation. The New Boston location is helping us with painting our parts, but also uses additive technology. I wanted to show one example over here. There are many other use cases where we use it for spare parts for maintenance or other components for jigs to make measurements easier. Some operational checks that we implemented with go, no-go gauges, etc. But I think this example over here is pretty interesting. So we always had a problem with our end-of-line testers. So an end-of-line tester is a system basically that checks the functionality of a seat structure in the end of a production line to make sure that the product is delivered in a good quality fashion to our OEMs. So the end-of-line tester actually connects with those gray connectors directly to the motor, and then operates the seat structure in order to make sure the function is given, and then take some measurements as well. And after the test is completed, of course, the operator have to unhook the structure again from the cable. And if that happens, then everything good. But as you probably also know, sometimes that does not happen, right? And therefore, we run into the problem that the cable is going to get ripped out. Two cases can happen, right? Either the cable rips out on our machine. That means we have downtime on the machine to actually fix that one pellet, right? Or the other case that can happen is that the connector breaks off on the motor, which then is more severe, because if not being catched right away, that could mean that we would send a faulty product to the customer, and of course we want to avoid that. That being said, we developed a 3D printed connector with magnet break-off. So as you can see in the pictures over here, there is a magnet in there holding the parts together. So that means if it wouldn't be disconnected, then the whole connector comes off without breaking anything. And that's what you can see here in those pictures. So yeah, in the first step, you can see how the employee actually has on the pallet the seat structure, which is connected to the end-of-line tester. Then in the second picture, you can see what happens if he lifts it off without disconnecting the cable. And on the third picture, you can see how the pigtail kind of bounces around over here because the magnetic connector helps. So that saved us a lot of downtime. And of course, the cables come all pre-manufactured from one of our suppliers, the original ones, and they are coming with a quite hefty price tag. So yeah, we also were able to save some costs and eliminate a quality problem. Yeah, now I have done a lot of talking. So yeah, if you want to as well, right, then please put your questions in the Q&A, and I'm happy to answer.
Yeah, that was great, Matthias. Thank you. There should be a second poll popping up on your screen. What is your biggest barrier in getting started with 3D printing? And then just for the Formlabs side, would you like to be contacted by a Formlabs product expert? So obviously Matthias has a lot of information on ROI and things like that that he can't share, obviously. So if you as a customer are looking to run through a similar process, those product experts, people like myself, would be able to go through taking your parts, what sort of technology would fit with it, and then give you, is this feasible? What is the best path forward, and things like that. So definitely worth your time if that is a problem that you're looking to solve. I'll move that up for another 15, 20 seconds. And then with anyone who has attended here, you can obviously request a SLS sample part. Best way to understand the capabilities of what we can do is obviously to see parts. So there should be a link going in the chat. And then again, there will be a separate link afterwards to contact sales afterwards. So there were a few questions in the channel that I'll go through. I think a mix between questions for Matthias, then a few just general questions. So just starting from top to bottom, is there a reason, question for you, Matthias, to use SLA over SLS for a smaller run of parts? Is this something determined by the material, the number of parts, whatever it may be? What's your thought process there?
Good question. So on the SLS side, the changeover of material is not as simple as it is on the SLA. So therefore, we usually use on smaller batches SLA. If we identify right from the get-go that the SLS material is what we needed, and certainly we printed in SLS, but in the most use cases, just to get some trial parts, we use SLA in the first place. What we have to keep in mind too is on the SLA side of things, it usually goes a little bit faster to print compared on the SLS side, and speed is definitely something that I'm looking for when we print the first off parts.
Cool. So follow up on that, is SLS faster? And then SLS faster can be a couple different ways. You have the print time, but you also have the associated post-processing time. That can be a big difference in terms of labor and things like that. Any comments there?
So when we print SLS parts, I would say the magic number for us is somewhat in the 20 area, where we say SLS is going to become faster. Reason being is, as Chris just mentioned, right, post-processing, etc. So on the SLS parts, the main topic is you have to break the powder cookie loose, right, after you print the part. And then from there, actually, it's fully automated, right? If you also have the tumbler, right, then you just put the parts in the tumbler and you're done, right? If you compare that to SLA, you have to print the parts with a support structure, so you have to keep that in mind. That the support structure has to get removed, and then sometimes you have to sand down the support structure areas as well a little bit, right? If you really worry about the surface, right? We use a vibratory grinder for that to automate that a little bit more, but that is something to keep in mind. So yeah, it depends on really depends on the sample size.
You know, if you can fit within a 8x5 by 8 build plate, Form 4 usually under an hour for small pieces, up to 6 hours for tall pieces. But if you're looking to do two dozen of them, it's not going to be necessarily same day if you're doing a full build area on the fuse, but you will be able to get overall higher throughputs and less overall touch points when you are making those parts, which is long term might be beneficial. Question on if a company cannot get their own SLS 3D printer, what third-party options does Formlabs recommend? So I guess first of all, usually lead with, you know, what's the barrier? Is it cost? Is it facilities? Is it whatever? Formlabs can obviously help answer that and see if there's some way around that. Formlabs does obviously offer the Fuse 1 Plus 30 watt. We do have a more cost-effective option in the Fuse 1. Still works very well. It is going to be the slower version of the Fuse 1 Plus and doesn't have as many materials. But if you are running with just a standard Nylon 12, it is going to be a more cost-effective option. With that being said, obviously not everyone can have a SLS printer in-house. So there are two different options that we can offer to customers. Formlabs does partner with quite a few service bureaus where they will basically run it as any Formlabs employee would. They know the materials, they know the post-processing, and they can help out with your kind of end-use goals there. So that's one option. And then another option, you know, in short-term runs, Formlabs will do, call it a validation run, where we can run a job or two and things like that for you at some cost, and you'll be able to get that short-term batch. Long-term, we will obviously send you over to our service bureaus. Question on material capabilities. So how do SLS nylon parts hold up inside a hot engine compartment or interior, things like that? So maybe Matthias, if you wanted to comment on the parts that you're printing, are they under any sort of mechanical thermal loads, or are they just outside of the engine?
So I would like to actually answer both questions here from Jim, right? Both kind of go hand in hand, to be honest. So yeah, that being said, first of all, yes, our seat structure goes through heat testing, heat and cold both actually. So we test everything from -40 to +90 C in most cases, right? So yes, the parts have to withstand all the, I would say, requirements like a injection molded part has to go. if it wouldn't pass, of course, we wouldn't have installed that in any of the vehicles or would have sent that part to any OEMs. So to answer your question, yes, they can withstand those. I have not tested those, or we have not tested those directly on an engine compartment. Or at least I have not done that. Brose does as well, climate compressors, etc. So there is probably something out there, but I can't speak to it right now. But on the seat structure, no problems at all. Just make sure that you kind of meet the material group that is called out, I would say, from your engineering team, right? That has been tested already, like the injection molded part, and you print with a comparable part, right? On the other hand, you were asking about the strength of the part, right? How that compares, which is, again, the same answer. So if you are in the same material group of your PA12 material with the glass fiber reinforcement, that's what we use primarily, right? Then we don't see a big difference. So it definitely happens that there is a slight difference. Sometimes the 3D printed part is actually stronger than the injection molded part, or vice versa. If we know that we print a part all the way to the end of lifetime, then we sometimes modify the part for the additive technology, because what you have to keep in mind too is usually we design parts for injection molding and not for additive technology. So yeah, we our design department is very well trained on the capabilities of additive technology, and then yeah, modifies the parts accordingly. Yep.
And
That
for
answers the question.
Regarding HTT, heat deflection temperature, the nylon 12 glass filled, it's roughly 350 degrees Fahrenheit, or about 175 degrees Celsius. And there are ways to even jump above that. If you're looking for, call it, non-standard applications, there are post-processing techniques like applying Cerakote, which is a ceramic polymer, or you can go through the process of electroplating to where you want similar chemical resistance and look of a traditionally tooled metal part, but you don't have the extra weight and the costing there. So, question on vacuum forming. So the high temp V2, it will have a an edge on all of our other materials when it comes to the allowable HDT, heat deflection temperature. However, what we've seen, depending on the longevity of those parts and kind of cycle times and things like that, I would consider looking into rigid 10K. So rigid 10K is another one of our, call it, high-end materials where we use them for injection molding tooling and vacuum forming tooling and things like that. And when it comes to longevity, the rigid 10K will, in most cases, last a little bit longer than the high temp. There are extra steps that you can do to elongate that lifetime, specifically using a secondary thermal cure after you would do your normal UV cure on the part. And then we also noticed that media blasting rigid 10K parts would help smooth out the surface and reduce micro stresses to basically, again, push that needle that will prevent ultimate failures and shrinkage and warpage and stuff like that. So another question on servicing parts and stuff like that. Again, we have service bureaus. We can do some short-term internal work. Obviously, reach out to Formlabs directly, and we can get you in direct contact with the best partner there. Matthias, so for your part control and you're doing end-use parts, how do you maintain that constant level of quality? Do you have a QC group? What sort of standards or specs are you adhering these parts to?
Mm-hmm. Yeah, good question. So we do 30-piece measurements from each one of the printers, right? Kind of to create a good size sample size. And those measurements, we do a scan, make an overlay, see what the variation is between those parts, right? And then adjust accordingly. It definitely needs some adjustment on the physical part or on the CAD model, I would say, introduced to the 3D printer to maintain those. And then from there, the printer has it after it's set up one time. But that's what we usually do, 30 pieces on the first run. And then we do additional pieces depending on the amount that goes into the build chamber, right? After that, every run. Yeah. But similar like you would do it with a serial production injection molded part.
And on the printer side itself, it does have a built-in maintenance schedule. Based off of print hours, it could be anything from clean your air filter to cleaning an optical cassette to whatever it may be. Most of it does come down to cleanliness of your optics and your filters and keeping powder out of areas where it's not supposed to go. Assuming you are following those steps, you won't see any significant deviation in terms of part quality or things like that. And obviously Matthias can talk about that.
Yeah, and like I mentioned earlier, right, for us, it's very important that it's not labor intense. So it is really, really fast. If you have a good vacuum, that's a tool you need, right? Yeah. So
Formlabs, SLS ecosystem, new powders. So yeah, it's a good question. It always comes up. Formlabs has always taken the stance of we would rather have a little bit more control over our manufacturing of the printers to go along with the materials that we certify and work on them. In most cases, we have at least one material that will work with your application. I know there are going to be some niche materials here and there that just won't work for us, for our printers, which is just sort of the nature of how we produce our hardware. Obviously, if there are certain niche materials that you are interested in running on a Formlabs printer, definitely let us know. We are constantly looking at what we have and don't have in our portfolio, and we'll be happy to see some viable use cases and potentially add it to our printers. I will make the case, though, at least on the SLA systems, the Form 4 and the Form 3, Form 3L, all of those, we do have a open material mode, a one-time purchase, and you can use any third-party material that you want. And then we are, as Formlabs, certifying some third-party materials that we will just be able to run as a standard, like just a GP, where we already have those preset settings. The other third-party materials that don't have settings, you'd run through like you would on a normal hobbyist printer, adjust the curing and the wiping and things like that. But again, you have full control over that with that open material mode. We have a customer working at a university, got the Form 4B, great to hear. What do you think the best way is to allow and teach students how to use a SLA 3D printer? So from what I've seen with customers and maker spaces, at least on the Formlabs side, the easy part is printing. The hard part is trying to find the best ways to design for additive in terms of geometries and overhangs and things like that. Because with the Formlabs side, we do have built-in checks to make sure you're running the right material, the right hardware, the right accessories to get that done. Difference is that you can set up the form file or your instructions many different ways. You can do custom supports, you can do all these orientations and things like that. So I think I would focus on that first. When it comes to actually utilizing the printers, we do have plenty of web pages online, tutorials, and things like that. If you want a virtual training session, I'm sure we can find someone on the services or sales team to support you there, depending on your area. But I think for the most part, we try and make our ecosystems as easy to use as possible. And you're not having to tinker around with it, whether it's, one person of no experience to another person with high levels of experience with 3D printing. It's all going to be the same workflow. Speaking on support structures in the SOA 3D printer. So Formlabs, the slicer software is preform. You can run it as a one-click print where it will do the orientation, do the support generation for you, and that will get you to a successful part. Success might be a loaded term depending on who you're asking and what that use case is for. Some may want to have as little post-processing time as possible, removing the supports. Some may want to save some money, whatever it may be. So you do have the ability in preform to take your supports. You can either auto-generate supports and then adjust afterwards, or you can manually go in and click every single little area that you want to generate those supports. You also have the ability to adjust the diameter of those touch point sizes. So if there are super intricate small features, you can dial down the touch point size so it will not remove any geometry afterwards. So again, might take a little bit of extra time to get those custom settings and supports generated, but it will be well worth the time if you are doing quite a large number of these parts or just very large parts. My personal preference, I will start off with the auto supports, and then I'll take kind of a glance through. If there's a super high density of supports, I may touch down the diameter and run that instead, and little things like that you pick up. Again, every single part of those, either generated by us or generated by you, will print. It's just a matter of how much material you're using and how fast it will take to post-process. Any preference there, Matthias, on how you generate your supports?
Yeah, we usually go a similar route. We reduce the thickness of the support to a minimum, then we let run the auto function and also remove like the additional ones. Yeah.
Mm-hmm. Question on tolerances on an SLS printed part. So yeah, we do have spec sheets online, generally within 4 thou, 5 thou. That will depend slightly based off of the material and the geometry and certain things like that. Again, it's one of those things where if you have a part in mind and you have set tolerances, send it to us. We'll print it, make sure it's within spec, and go from there. I'd rather just do it that way as opposed to rely on the spec sheets. Is there a greater need for post-processing like blasting, polishing, grinding, or vapor smoothing? So now, Matthias, you mentioned some need for that. Is that for the aesthetic or just to save you some time?
So for the powder printing, we only use blasting, right? And then the part has already the, I would say, surface quality that we need. On the resin prints, sometimes we use polishing, like vibratory grinding after the process, but it is only to remove the support structure in a more, I would say, automated fashion instead of doing it by hand. So, but generally speaking, the print quality is good enough for what we need. So we do not do any vapor smoothing or any other chemical processes after.
Yeah, again, all of the parts, they are compatible with that. It's just up to your end needs.
Mm-hmm.
So resin printing in an automotive environment. So it depends on the longevity, depends on the use case. You can do SLA jigs and fixtures. They're not going to last as long as SLS, but everything has its use case if it's going to be short term. Matthias, any comments there?
Yeah, like mentioned earlier, we use the resin printers not for end-use parts because of the UV resistancy, but everything else that Chris just mentioned, like first offs, etc., rubber materials, we for sure use a ton. And yeah, we build a part for every third vehicle in the globe. So yes, we use it a lot in the automotive world.
Can you use either SLS or SLA printing to create a mold for low volume injection molding? Yes, we do. We've done it in the past. Many of our customers are doing it. We do have a white paper that will go through the exact material, process conditions. That's including the pressure, temperature, cycle time, number of cycles. Some common materials that we use in that case study, it was HDPE, PA6, polypropylene, and then the printed materials that we use to make those molds were in rigid 10K, high temp, and then I believe Gray Pro for some call it room temperature molding. Can you also make a seat handle? So this is regarding kind of UV stability and how that reacts over time. Have you tried it, Matthias?
Yes, quite a ton actually. So yes, we use seat handles over here that we 3D print on the resin printers just for our prototype applications to give the technicians that actually build the seat structures on a workbench level, right, an option to move the seat around. So yes, therefore we print it in resin. We have not used it for any end-use parts, but because of the, and you mentioned it over here too, the UV resistance, I would not recommend this using for resin part. But the powder should not be an issue. I don't see a concern with that.
Yeah, I mean, the general story is as these thermosets or resins get exposed to more UV light, they will either discolor or start to become more brittle. If the part is going to be sort of behind the scenes, just sitting there as an enclosure or something, that would be applicable and working. But if it's, you know, subject to constant mechanical load or things like that, you may need to consider a SLS material instead. Okay. The next question, get this question a lot. Will there be a Form 4L? That seems like the logical step based on what we've done thus far with the 3 Plus and the 3L. I don't know of anything or any timelines yet. I'm sure as soon as I know, you'll know on our website or via email or whatever it may be. Is it possible to print in place living hinges in an SLA? So with the SLA technology, it is going to be a single material printing process. So if you want living hinges, we do have materials that are similar to polypropylene. We call it Tough 100, to where you can print thicker sections on one side and then thinner in the middle, to where it will be able to bend back on itself and then return to its original shape. If you want something more than that, I would recommend kind of a two-stage process where you print 2 different materials, say a silicone 40A and then a tough 2000 to then get assembled with it, and then you can have the full piece that way. If you want true print in place articulating models, then I would steer you towards the SLS process, because there are no support materials being generated, so you can get very creative and you have a lot more freedom printing in that 3D volume as opposed to the called a 2D plane against gravity with SLA. How do mechanical properties of SLS printed parts differ from raw/bulk material? Again, if you're in that same nylon 12 category, going to be roughly the same. There will be some slight deviations depending on your exact orientation. They are not completely isotropic. They're close, but they're not perfect like the SLA materials. Yeah, usually if there's certain mechanical loads that are going to happen, what we'll do in the setup of your files, if you are 3D printing them, we will make sure whatever applied forces are going to be perpendicular to your layer lines. That way, that will be the strongest area, the strongest section, to where you won't see any part failures or things like that. What is the most optimal way of printing threads on the SLS and SLA printers? Yep, another good question. We have a white paper that goes through it, support pages. The short story is the SLA printers can generally do smaller thread sizes. You just need to be wary that if you're comparing super small threads, their allowable usage, comparing that to heat inserts or pressure fit inserts of more traditional materials, those pressure inserts are obviously going to work a little bit longer. It depends on how many times you're going to be assembling those parts together and back and forth. So from what I've seen, anything under like a M4, M5, I like to go for the heat insert route. And then if I want to be, I don't know, a little creative, what I can do is just print a hole, undersize a little bit, and then I can tap it afterwards, and that'll be, not too bad. It might be a little bit easier than printing, especially if it's a very small thread size. Matthias, are you working with any assembled parts, either 3D printed part to another 3D part, or how does that all work?
Yeah, what we use a lot on like jigs are those, they make those copper inserts actually that you can press in, like those that you can buy at like the regular big box store, right? And yeah, we use those press-in inserts. They make those for plastics as well. So we do similar press-in the threads actually, tapping the threads. We we had, I would say, mixed experience, right? But yeah, therefore, with the inserts, you can choose everything from from M2 to all the way M12 is available like in regular market, and it works very well. Have used it quite a lot. Yeah.
Yep. So yeah, to your next question, Carl, yes, you can use heat inserts in a SLS 3D printed part. SLS parts, they are thermoplastics, so you can heat them up and then they will melt back down into a solid shape. So usually you take the heat insert, put it next to a soldering iron, you use that soldering iron, just kind of push it in, heats up everything around it, and then that will set in place and you can use it for all sorts of use cases. Good. So I believe that's at least everything in the Q&A section. There might be a couple in the webinar chat that I may have missed. Printing metals, so no, Formlabs, we are sticking in the resin and nylon family. However, there are post-processing techniques that you can undergo to get parts looking or having similar chemical and surface abrasion properties. Question pop up, how much would prototyping directly with Formlabs cost? It depends. I mean, again, look, you have service bureaus, call them mom and pop shops where they have a few printers and that's their job. You have large online service bureaus like Xometry and I guess not Shapeways anymore, but similar companies. They will have their own ways of going through costing and things like that. It will vary based on the material, based on the number of parts that you're requesting, and if you set in any specific post-processing techniques, if you want it polished or dyed or whatever it may be. So yeah, reach out to us directly, give us the specs, give us the parts, we'll get you direct costing, and then from there we can help you use that information to compare to other companies, other ways of getting parts, and see what's most cost effective for you. Yeah, we'll follow up on any specific links that I mentioned, white papers, case studies, things like that. Yeah, if you have time, I think if you Google Formlabs, whatever, there's usually something pertaining to it, injection molding, dyeing, anything like that. So with that being said, we are 2 minutes of time. Give you all 2 minutes back. I want to thank you all for your time. Thank you, Matthias, for your time and your bucket full of information. I'm really excited to see end use parts, especially on the X7 and those cars there. So very happy for it, and want to wish you all a good rest of your day. Thank you.
Hey, thanks everybody. Appreciate it. Bye.